Okay, the old tree walking algorithms. Now, the great thing about the tree walking algorithms is they're inherently simple because they use recursion. Okay, so the three standard ones that we've got to remember are pre-order, in-order, and post-order. But you only really need to remember one, and you can work out the others from that one. Okay, so it's all about the order that we process the data in a node. So in these ones, we're just like, let's say we're just displaying a list. We're outputting the node values from the tree. Okay. Now, if we start with, well, let's just do a standard walk, right? And we'll use the Perry method. Okay. So we're going to let's do the pre-order traversal. Okay. So let's cut before from the centers of each node. So this is the manual tree walk method, and then we're going to let's make that one a bit long. Right, then we're going to start at the top and we're going to go anti-clockwise around the tree, cutting. So we get 45, we go 20, keep cutting, we get 13. So it's where them lines that we just drawn, the pre-lines, where they are. Oh, don't do that to me. Oh, I don't want to carry that on. Where they cut, that's when we write down a node value. So 27. Now, this isn't going to make much sense to us. 24. But this is the list that you would get if you pre-order traversed this tree. Nothing being cut, nothing being cut. 56. And then I'll relate this to the little recursive algorithm. So 65, 2 more to go, gonna run out of space. 59. Put some commas in there. So it's an actual list of numbers. And carrying on, 70. And then it finishes. Okay, so comma 70. So that was the pre-order traversal of it. Now, if we look at this pre-order algorithm, we're saying as long as we haven't got an empty node, so is the node not null? So we start off with the root, so the root is where the 45 is, so that's root. Okay, and we say, right, okay, let output the node, which is exactly what we did. We processed the node before we did anything, and then we said, right, we'll follow the left branch. So we follow the left branch. Every time we follow a branch, we're running this subroutine again, so we're recursing. And we say, right, well, as long as it's not null, output the node. So we output the node. And then we follow the left branch. So we follow the left branch and we get to the 13 node, which isn't null, it's got value, so we output the node. Then we say follow the left branch. So we follow the left branch, but there is no left branch. So we end the recursion. So this is our stopping condition. So once we've traversed the left node, and we found out it was null, we go back and try the right node. So we go down this one. And then when we hit a node, we process the data, so we output the 27. Okay, so we end up with 27. We then follow the left node, so we're always trying to go down the left branch all the time. We get to another node, 24. There is a node there, so we output the data, 24. Then we try and follow the left node. Oh, it's null, so the recursion stops. End up back at the pre-order node.right. Try and follow the right node. There is no right node, so the recursion stops. We go back up. We'd follow the left node. Now we're going for the right node. There is no right node, so we go back up. Okay, and then when we get to the 20 node, we've done both traversals, so we just end. So the recursion ends again. Then we get right back to the 45 node. We follow the right branch. We've got a node, so we output the data. Then we try and go left. There is no data, so we go right. Output the node, 65. Try and go left, there is a left, output the node, 59. Try and go left, there is no left. Try and go right, there is no right. So that's the end of the visit of that node. We go back up to the 65 where we follow the left branch, then we go to the right branch. So the final part of the recursion for this Get to a node, output the 70. Try to go left, there is no node. Try to go right, there is no node. End of recursion. So we've ended up visiting that order. Okay, now let's see if I can work out how to select all of this and delete it, and we'll start again. Oh, I don't know how you do that now. And we'll have a look at the Inorder Traversal. So it's the same structure. Okay, so to do Inorder Traversal using Perry's method, draw lines down from the center of each node. They're going to be our cutting lines that tell us when to output the node data. Go anti-clockwise round, so you can see nothing to see here. And you can see in the algorithm that we traverse left nodes before we process any data. So when we got to the end of a left branch, then we can process nodes, and that's what the manual traversal is going to show us. So carry on round, yes, cut. So write down 13. Keep going round, 20. Keep going round, left branch to follow. No left branch, output the 24. Again, let's put some commas in. Keep going round, cut by 27. Keep going round, cut by the 45. Now you can see what we've done, we've managed to follow all the left nodes down. We've from the 45, from the root node. We just outputted the root node, now we're going to follow the right branch. But when we get to this, we try and follow left branches. So you'll see that happen now. So we go down the right branch, get to a new node, try and follow, there is no branch. So the next action will be to output the data, and that's what the cutting is going to tell us. So the cut says 56 to be output. Carry on down. There is a left node, so we're going to follow that left node. There is no left node, so now we're going to output the data at that position, 59. There is no right node, so we finished recursion on that. So we go back up to the 65 node that we were processing, output the data there. So we're in the middle of the recursion here, this bit. We then follow the right branch. We then get to a new node, which tells us to follow a left branch. There isn't one, so we output the node data. We then try and follow the right branch. There isn't one, so we've finished the recursion. So it matches the manual. Okay, so the algorithm is essentially the same, and you can see if we go for the post order, it's the node that is processed last, but it's always left and right. So where the node processing of the data goes is the name of the traversal method. So in pre, the node is processed first. In order, it's processed in the middle. In post order, it's post after you've done the left and right. But it's always left, right, left, right. Now I did ask you another question, which was how would you do a reverse list, assuming we had a list of ordered numbers like this. Okay. Now all you've got to do is, instead of following the left branch before the right branch, you just switch those round. So you just do Inorder Traversal, but you go right branch, left branch. So it's identical. Okay. And this is what makes tree structures so nice, is that the code to actually visit every single node is really trivially simple, if you can get your head around recursion and the simplicity of it. Sometimes it looks too simple. Okay, but don't forget the manual tree traversals. Remember, if you're going to do post-order traversal of a tree manually, draw all your cuts. Let's just delete all that junk. Draw all your cuts going that way. Alright, so when you go round, you go 13, 24, 27, 20, 59, 70, 65, 56, 45. So always in post-order traversal or reverse Polish traversal, your root will be the last value you whack out. Okay, so that'll be a quick double check. Okay, right, done with that one.